a little bit about the structure of water and the discussion of naming. Is it a hydrogen ion? Is it a proton? Is it a hydrogen ion? If you remember the structure of water, and there's a picture here, you've got the oxygen the oxygen and two hydrogens in a V-shaped structure. And the oxygen is pulling from electrons from the hydrogens. It's more electronegative than the hydrogens. It's more capable of the two electrons that are shared between the oxygen and each of the hydrogens. Yes, they are being shared. This is a covalent compound, but they mostly are under the sphere of influence of the oxygen. It's a stronger pulling from those electrons. So there is what we call a partial negative charge around the oxygen. And that is what we mean with this delta minus. That's what means partial negative charge. It's not a proper positive or negative charge. It's an excess of electrons in the area of the oxygen. And apart from the electrons that is pulling from the hydrogens, from the hydrogen bondings, the oxygen has two pairs of electrons sitting on the oxygen as part of the oxygen structure, electronic structure, that are not being used in the bond, but they are there, and that's what gives the V shape to the molecule of water, because you have the two electron pairs from sitting on the oxygen that are occupying a space, and that pushes the hydrogens in a sort of V shape. So when you have a compound like HCl, again, if you think of HCl, it's a covalent compound. The hydrogen and the chlorine are sharing those electrons. But chlorine is stronger than hydrogen attracting those electrons from the pair. So they spend more time being controlled by the chlorine. It's more electronegative. That's what we call a polar bond. So the electrons are shared between hydrogen and chlorine, but they are mostly controlled by the chlorine because it's stronger pull in them. That means that you have a partial negative charge around the chlorine, that's where most of the electrons of the molecule are concentrated, and a partial positive charge around the hydrogen. And that's the interesting thing. Then you have a compound that has an excess of negative charge in the form of these electron pairs near a compound that has an area, the hydrogen, that has a lack of electrons, a partial positive charge. And that's when you get the reaction, and the oxygen, one of the electron pairs from the oxygen, attracts the hydrogen from the HCl, but not the electrons. It takes only the hydrogen with a positive charge. The electrons stay behind with the chlorine, because they were more attracted to the chlorine than to the hydrogen to start with. So when the bond breaks, it breaks through here, not halfway through the middle, or with electrons going with the hydrogen. No, the electrons stay with the chlorine and becomes a chloride anion, a chloride. And the hydrogen with a positive charge, no electrons, goes to the sphere of oxygen, influence of the oxygen. It becomes bonded to the oxygen, and you end up with what we call a hydronium ion. This is H3O plus. H2O plus added one H, but with a positive charge gives you this H3O plus. So if you notice, in the previous slides, I've happily talked about hydrogen ions, I've talked about hydronium ion, I've briefly talked about proton in one of the slides, and you're like, hang on a minute, are the three things differently? No, unfortunately, we use the three words interchangeably. When we say it's a proton, or an acid releases protons, an acid releases hydrogen ions, an acid releases hydronium ions, we mean the same. Sometimes we write H plus, and sometimes we write H3O plus. So sometimes I will go and write, how does hydrochloric acid behave as an acid? If I write it like this, I will write, well, hydrochloric acid is an acid because it liberates hydrogen ions. And then the corresponding fragment of the chlorine, which is a chloride anion. But sometimes I will want to write, HCl plus water. How does hydrochloric acid react in water? Well, a hydrochloric acid is an acid. It donates hydrogen ions. Where do these hydrogen ions go? They go to the water. that is going to be accepting them. So if the hydrogen goes as an H+, you end up with the chlorine with a negative charge on its own, and the hydrogen as H+, has reacted with a molecule of water and given you H3O+. And even if they look different, both reactions mean the same. It means hydrochloric acid is an acid and is liberating hydrogen ions. If you think about it, hydrogen has only one proton and one electron. If hydrogen were going to lose that electron and become just the proton, you literally would have a proton, so a nucleus with no electrons. That would not be stable. That will be too reactive. You're not going to have a nucleus of hydrogen floating in your solution. What you have is the hydrogen without electrons attached to a molecule of water to give you this H3O+ structure. So that's what we sometimes call hydrogen ions protons, and you will see that in many cases we talk about protic acid, protonation, and it comes from, hydrogen ions could be conceptualized as a hydrogen that has lost an electron, and it only has the proton. In practice, in reality, that's too unstable, will not exist in solution. What you have is the compound H3O+, that is properly called, or technically it is called hydronium ion, but to be completely honest, very rarely that word is used. Hydrogen ions or protons are probably the most common words that you will use when referring to this acid-base chemistry. I tend to use always the word hydrogen ions because I think that proton can be confusing. Protons sounds like protons, neutrons, electrons in the structure of the atom, but the word proton is quite common, and you need to be comfortable when maybe you will come across in a video or in a textbook or in some of your reading.